At the beginning of this section, we're just going to get some practice working with our chi-square probability table. This is not something that we'll be using too terribly often, but it is something that I want to just get some practice working with. It helps you to understand what the chi-square distribution looks like and what the different things that we need to find a p-value for a chi-square test will look like. So in each of these cases, we really need to know two things. We need to know, first of all, what is our chi-square value for these types of tests, because we're working with a chi-square distribution. That means that our test statistic will be a chi-square value. So normally in the last sections, our test stat in these types of hypothesis tests have always been z, and that's because we were working with the normal distribution. That is no longer the case for this section and moving into Chapter 7 as well. Our test statistic will no longer be z, it'll be this chi-square value. So our test statistic is a chi-square value that tells me what type of distribution or what type of probability table I'm looking at. The other thing that I'm going to have to know then is what are my degrees of freedom. So in this case, I have 6 degrees of freedom. So my chi-square value is 10. My degrees of freedom are 6. So I need my chi-square table. Those should be linked right above in the notes above, but they're also linked in our Canvas modules as well. I need to hop over to my probability table, so let me do that here. We said for this type of problem, chi-square was equal to 10, and my degrees of freedom are 6. So I'm going to start by looking at my degrees of freedom here. So my degrees of freedom here in this case are 6. That tells me what row of my table I'm looking at. So I'm just going to find degrees of freedom 6. This means I'm looking at this row right here because this column tells me my degrees of freedom. And then after that, I'm going to look for where does 10 live in these rows of numbers. Now, it is certainly possible that 10 will not be included here. We're not going to get exactly 10 here. When we work with these probability tables for chi-square, it becomes more difficult to find an exact p-value for these types of problems because unlike the normal distribution, there are infinitely many chi-square probability distributions, and they all look a little bit different. So depending on what our chi-square value is, we may not be able to find an exact p-value, but we can usually get a pretty good idea of what it is. So what I'm going to look for is all of these numbers within this row represent chi-square values, and I'm going to find where does 10 live in relation to this. So first of all, it's not between 7.2 and 8.56. It does, however, live between 8.56 and 10.64. So the other thing that I'm going to look at then is what areas does this correspond to. For chi-square distributions, we only ever care about area to the right. If you look at our distribution up here, that's the part that's shaded. So we want area to the right, which it tells us right here, is somewhere between 0.1 and 0.2. Now, I can't say exactly what it is without using some other technology like my graphing calculator. We'll talk about that in later sections, but for now, the best I can do is to say, well, my p-value is going to be somewhere between 0.1 and 0.2, which feels frustrating because, yes, we don't know exactly what it is. However, that would still be enough to make our decision at the end of our hypothesis test, because you could compare that to alpha. You could say, well, it's bigger than 0.05, so that means we're not going to reject. That at least gives us something to work with. So we said between 0.2 and 0.1. So let's go ahead back here and mark those up. So our p-value is between 0.1 and 0.2. So it's between these two values. Very cool. Let's talk about the next one. So the next problem that I'll be looking at has a chi-square value of 17 with 9 degrees of freedom. So chi-square is 17. My degrees of freedom are 9 here. So hopping back to my probability distribution, I'm going to erase what we have just so we can start fresh. And we said chi-square equals 17. Degrees of freedom are 9. So I'm going to start with my degrees of freedom again. Remember, that's this column over here on the left. Degrees of freedom are 9 means we're looking at this row. And I'm going to look for where does 17 live in this row. So it's not between 10.6 and 12.2. It's not between 12.2 and 14.68. It's not between 14 and 16. It is, not between 16 and 19. Actually, no, I just lied. It is between 16 and 19. I was thinking about a different number. So 17 lives somewhere between 16.92 and 19.68, which means that our p-value, the area under the chi-square curve, will be somewhere between 0.02 and 0.05. And if you would imagine for a moment that we were doing a hypothesis test, well, if it's between 0.05 and 0.02, that means it's less than 0.05. So if my alpha, my level of significance, was 0.05, I would reject H0, which is really the important part of our hypothesis test, is that decision we make at the end of our problem. So it's between 0.05 and 0.02. So hopping back, our p-value, our area here, we said is between 0.02 and 0.05. Wonderful. We've got that one down. Last problem that we will take a look at here. This time around, we want a chi-square value of 30 and degrees of freedom 10. So we have to hop back to our probability distribution here. And let's just erase what we have. So our chi-square value this time is 30. Degrees of freedom are 10. So starting with degrees of freedom, we're looking at this row right here. 10 degrees of freedom means we must be looking at this particular row. And I'm going to try and find where does 30 live. Well, it's not between 11 and 13. It's not between 13 and 15. It's not between 15 and 18. Not here, not here, not here, and not here. If I imagine where 30 lives in relation to these numbers, well, it's bigger than 29.59, which means it must live somewhere over here. It lives somewhere to the right of that 29.59. So what I need to do then is to imagine if I was to continue these p-values over here, these areas above, what would that look like? Well, I know it's going to be somehow related to this 0.001, and if I look at what happens as I move to the right, from 0.02 to 0.01, and so on and so forth, every one of these numbers is getting smaller as I move to the right. So all I can say about my area, or my p-value in this problem, is that it is less than 0.001. So hopping back to my problem, all I can say is that this area, this p-value, is less than 0.001. So again, in all of these types of problems, we're